So now, remember when you have like a power n times a power m, it is a power n plus m. We just add powers. I think you remember. When they have the same base, we just add powers. So here we have 2 power n over 2 and 2 power 1. We're going to add powers. So finally, 1 plus I power n plus 1 minus I power n is the same as 2 power n over 2 plus 1 cos n pi over 4. That is the answer. For 1 plus I power n, then plus 1 minus I power n. So then, the second one, it is 1 plus I power n minus 1 minus I power n. So what is that? So we have the value of this, which is 2 power n over 2 cos n pi over 4 plus I sine n pi over 4 minus the value of this, which is 2 power n over 2 into bracket cos n pi over 4 minus I sine n pi over 4. So finally, you see 2 power n over 2 is common. We take it out of the bracket, 2 power n over 2. So that is cos n pi over 4 plus I sine n pi over 4. Then minus cos n pi over 4 plus I sine n pi over 4. We close the bracket. So look here. The real part, this cos n pi over 4 with cos n pi over 4. So cos n pi over 4 minus cos n pi over 4, that is 0. I sine n pi over 4 plus I sine n pi over 4, that is 2I sine n pi over 4. So finally the answer is 2 power n over 2 into bracket 2I sine n pi over 4. So what does it mean? The answer is, as I told you, when you have the same base, we just add powers. You write one base, then you add powers. So I have 2 power 1 here with this 2 power n over 2. The answer is 2 power n over 2 plus 1, then I sine n pi over 4. So which means that 1 plus I power n minus 1 minus I power n. The answer is 2 power n over 2 plus 1, then I sine n pi over 4. So that is the answer. So that's the answer for number 6A and B. So I think there is no any question. Let us go to number 7. You are still with teacher King David. So let us go to number 7. Number 7 is saying that let z equal to negative 12I root 3 plus 12 and t equal to negative 6 root 3 plus 6I. So remember that we are doing revision questions about complex numbers. So now that we have z and t. So where w equal to z over t, it is a complex number. So now 7a, it is saying that compute the modulus and argument of z and t. That is 7a. So this number 7a and b, it is number 7 Reb 2008. So then b, it is saying express w and w power 6 in their polar and standard forms. So let us start with a. A is saying to find the modulus and argument of z and t. So what is z? Z is negative 12 I root 3 plus 12. So what is t? T is negative 6 root 3 plus 6i. So we're going to find the modulus and argument of that one. So the modulus of z, what is the modulus of z? Remember, if you have z equal to a plus bi, so what is the modulus? It's the square root of a squared plus b squared. That's how we know that it is what? A squared plus b squared. So now our a It is 12 because z is written in form of 12 minus 12 root 3i. So which means that the modulus of z will be root 12 squared plus negative 12 root 3 squared. So what's the answer? This is the same as 12 root 1 plus 3 because square root of, root 3 squared, it is 3. So finally this is 12 into bracket, this is root 4 is 2. So the answer is 24. So now the modulus of z is 24. So how have I done this one? You see, I have 12 squared, even here I have 12 squared. So 12, when you have root AB, is the same as root A times root B. So you see, I have root 12 squared into bracket because 12 is here and also it's there. So it will be 1, I remain with 1 here, and here I remain with negative root 3 squared. So square root of 12 squared, that is 12. Then root 1 plus, what is root 3 squared? That's the 3. That's what I have done. So let's go to t. T is negative 6 root 3 plus 6i. Then the modulus of t is root negative 6 root 3 squared plus 6 squared. You see 6 is common. Here there is 6 and even here there is 6. So 6 squared, that's 36. Root 36 is 6 into square root. Root 3 squared, that is 3. Here remain is 1 plus 1. So 3 plus 1, that's 4. Root 4, that is 6 times 2. So which means that the modulus of t is 12. So after that, we're going to find their argument. So we're going to find the argument of z. What is the argument of z? So tan alpha, we have z equal to 12 minus 12 root 3i. So our A is 12, our B is 12 root 3. I told you don't consider negative. Negative comes when we are checking the where Z is located on a circle. We use negative when we are checking where Z is located on what? On the circle. So then tan alpha always equal to B over A. So tan alpha is B 12 root 3 divided by 12. So tan alpha equal to root 3, where alpha is tan inverse of root 3. So then alpha is, let us use the calculator to find tan inverse of root 3. Tan inverse of root 3 are going to see tan inverse of root 3. The tan inverse of root 3, shift tan inverse of root 3, it is 60 degrees. 60 is pi over 3. So our alpha is pi over 3. So let us go to the circle to know their location, where it is on which quadrant. So we have A, it is on a positive x-axis, because it is positive, it is here. But B, it is on negative y-axis, because we have a negative here. negative y-axis. You see, they meet on fourth quadrant. So on first quadrant, angle equal to negative alpha. So which means that our angle will be negative pi over 3. That is our angle. So which means the argument of z is negative pi over 3. So that's the answer. So let's go to t. T is negative 6 root 3 plus 6i. So what is the argument of t? What is the argument of t? So tan alpha is b over a. b is 6, a is 6 root 3. So this is 1 over root 3. So alpha is tan inverse of 1 over root 3. So now alpha, tan inverse of this is pi over 6. It is pi over 6. So we're going to check which quadrant does this one located. We have a circle. You see x, our a, it is on negative x-axis, which is here. But y, it is on positive, b, it is on positive y-axis. So you see they meet here. There, it is in the second quadrant. It is in the second quadrant. And in the second quadrant, angle equal to pi minus alpha. So therefore, our angle will be pi minus pi over 6. So which means that the angle will be equal to 5 pi over 6. So which means that the argument of t is equal to 5 pi over 6. That's the answer. 5 pi over 6. It is 5 pi over 6. That's the argument of t. Do you have any question on number 7a? I hope there is no any question. If there is no any question, let us go to 7b. So now we are going to b. Express w and w power 6 in their polar and standard form. So what is w? Remember, w is z over t. W equal to z divided by t. And if you remember, z it was negative 12, I root 3 plus 12. And you got its modulus. You got that modulus of z, you got 24. And you got the argument of z, we got negative pi over 3. So which means that we can express this z in the polar form, where z is r into bracket cos angle plus I sine the angle. So our z is, what is r? 24 into bracket cos of negative pi over 3 plus I sine of negative pi over 3. That's z. So what about t? T, it was negative 6 root 3 plus 6i. So we can convert this t into polar form, because we got that the t modulus, it is 12. The argument of t was 5 pi over 6. So now, t in the polar form is r into bracket cos angle plus I sine angle. So our t will be equal to, what is r? 12 into bracket cos 5 pi over 6 plus I sine 5 pi over 6. Then finally, what is w? Remember, when you have z1 over z2, from z1 over z2, which is r1 into cos angle 1 plus I sine angle 1 divided by R2 into bracket cos angle 2 plus I sine angle 2. Remember, when you have quotient like that,